All right, so we are in geometry. We are in lesson 8-9. Today is Monday, March 18th, 2019. Last Friday, a few of us were gone, but we learned how to we learned how to graph a circle. Now we're going to go backwards and be given a circle and have to come up with an equation. So to start off, let's do some review. What is the standard form for a circle? The standard equation. We got one hand. We got two hands. Anna, go for it.
X plus h squared.
X plus h, and then that quantity squared, right?
Quantity squared. Minus, plus y plus k squared.
Quantity squared, yep.
Equals r squared.
R squared. You are so close. I'm going to give it to you, though. Martine, you want to correct her?
It's x minus h and y minus h.
Yeah, the only correction I can make is this plus should be a minus, this plus should be a minus, and that represents the fact that you are supposed to switch the x and y coordinate of the center whenever you get it. So the reason that those are negatives is just remember that you should be taking the opposite of whatever number here to get the center. Yeah, thank you, Anna, and thank you, Martine. You both have your participation cards in. There's my YouTube channel, and Anna is in. Do you have a question, Ellery?
Why are they squared?
Why are they squared? Good question. So in order to make a curve, you need to have something to the second power or higher. Martine, there you are. Yeah, so in order to, that's the basic reason. If we actually did a more in-depth geometry class, then I could show you more in-depth why those have to be squares and not cubes or to the power of fourths. But for now, this is an equation, and we will have to be able to regurgitate it. That makes me sad having to give that response, but if you want to come in during break or at lunch, I can explain it more in depth if you'd like. All right, so that is our standard form for an equation. That means if I am trying to get from an equation to a circle, I'm going to have to take the opposite of whatever's here. So write it down. In order to get to, actually we'll write this down. So in order to find the center, the center is going to be h, comma, k. The radius is going to be r. This is all review. If you gentlemen can continue to talk, I'm going to have to separate you. Oh, and I need to get these up here as well. So far we have Anna and Martine in. So we have 2 marbles to add. 1, 2, 1, 2. All right. So now we need to be able to convert back and forth. I want to show you both directions, that way we can connect the two in our heads. So I'm going to go ahead and rewrite this equation. So let's go ahead and rewrite it right in the center here. I'm going to do x minus h, that quantity squared, plus y minus k, that quantity squared, is equal to r squared. All right, my first direction is going to be going to a circle, because that's what we did yesterday. So to get from R to the radius, to get to this radius right here, maybe I should make it a straight line with technology since I have that. In order to get to here, what did we have to do to this whole number? Beverly. Square root. So do the square root symbol, or this radical symbol. Thank you, Beverly. Scroll up here. Beverly, there you are. All right, in order to find the center, what do we have to do to these two numbers here? This negative h and this negative k. What's the best way of doing it? Coming out here and coming to the center. To get this h and k, to get to the center, what did we have to do? India. That is correct. Take the opposite. All right, now we're going to go the other direction. Now I'm going to be giving you a circle. So now if I have the circle and I want to do, let's start with the radius. this radius to get to r, instead of going to the square root direction, the opposite of that should be quiet raised hand. If I have a radius, in this case the radius was, went from -2 to 4, so the radius was 6. In order to get from the radius of 6 to an equation, what do I have to do? Quiet raised hand. You can still raise your hand without a card if you want. I'm giving preference to the people that have cards. I see India's hand. I see Beverly's hand. Yeah, Loretta, go for it. Careful, so it's not multiplied by 2. It's the opposite of a square root, so it's to the power of 2. So the opposite of square root. This is a square root. You just want to say square. Yeah, there it is. So take that and then square it. Square it. Or if you want to do something like x to the power of 2 and you know that that means square it, that's great. But I'm going to write out the words square it. So square the radius to get back to the radius. So Lorea is in. And then finally, to get from the center back to these 2 points, what do we have to do to those x and y coordinates? Ellery? Take the opposite. So Ellery is in. So there is Lorea's marble. There is Ellery's marble. All right, now we can go back and forth. That is not the most neat diagram, not the neatest diagram I've ever made, but there it is. So for the x and y coordinates of the center, take the opposites, both directions, forward and backwards. The radius is really the tricky bit. If I have a circle and I have a radius, make sure to square it, and then if you're trying to get to the graph, then you need to square root it. All right, we have that diagram down. Here we go. We're on to example 1. We need to make an equation for this circle. I will give you the basic format. Here it is. It's going to be, I'll write it on the very top, it's going to be x something something squared plus y something something squared, giving yourself room to write a plus or a minus and a number, is equal to a radius. So I have everything filled in aside from the center and aside from the radius. I need a quiet raised hand to help me find what numbers go with the x's, what numbers go with the y's. Tell me what the center of this is. Tell me what the coordinates of that center are. I see 3 hands, the same 3 people over and over. I want to try to open it up to more people so more people can get their cards in. Leo, do you want to give it a shot? No? Caroline, you want to try it? So -2 and 1 like that. You're really close. You need to do this to it. So it should be a -1 and this should be a +2. Exactly. Yep, and Caroline has it. So this should be a +2. I'm taking the opposite of the coordinate. So this original coordinate of the center, this point A, was in the x direction we went -2. -2. In the y direction, we went +1. So Caroline took the opposite of the x coordinate and stuck it with the x. The opposite of -2 is a +2. The opposite of the y coordinate, the opposite of 1, is a -1. So Caroline has done the center for us. Now we need to figure out the radius, and that can be a tricky thing to do. So Caroline's card is in. Caroline's marble is in. Like 3/4 of the way to a pizza party. Question, Jaden? Ask the question. Other people probably have the same question.
Yeah, I have 2 questions.
It's not two.
Oh, then maybe not.
It's just marbles.
Okay. You can ask me after we're done with the notes.
Where's my participation card? Like, where's my card at?
Did it not get passed out?
Did it not get passed out? Or did
So,
I
Jane, you have it.
participate?
All right, so now we need to find the radius. And the radius is going to be pretty tricky. So the radius, and I'm going to move these coordinates down a little bit so we can see what's going on. So this radius right here, go ahead and draw a line in your notes. This radius from A to B is the thing that we're trying to figure out. The length of this line segment. The problem is it's diagonal, which means we can't just count up squares. Luckily, we have a theorem that tells me the length of diagonals. Does anyone remember what that theorem is? And I don't see hands, so I will start giving you a hint. Here's my hint. Draw a line right here and right here. Now, can anyone tell me what that theorem is? I see one hand. How can I figure out the length of this diagonal line? I'm just asking you the theorem or the general way of finding it. 2 people know. 3 people. Aurelio. It is indeed the Pythagorean Theorem. It deals with right triangles, so our Pythagorean Theorem is the thing we're going to be using. This is a right triangle. All right, so the Pythagorean Theorem, Aurelio, you have your card in. Thank you, thank you. Oh, you actually are using Class Dojo. I will come back and give that once it loads. Yeah, so who can tell us what the Pythagorean Theorem is? Quite raise hand. Who can regurgitate that theorem? You will be using this all over the place for the SAT for my class. Beverly? It is indeed a squared plus b squared is equal to c squared. And Beverly, can you do one additional step? Can you tell me what numbers to fill in for these? And I'll go ahead and count these for you. 1, 2, 3, 4, 5. This length is 5. This length up here is 2.
5 squared plus 2 squared.
That is indeed correct. So 5 squared plus 2 squared is equal to c squared. And again, it doesn't matter if I did 2 squared plus 5 squared or 5 squared plus 2 squared. You will still get the same answer. Do you have a question, Anna? The hypotenuse is always c, yes. We'll make that note as well. This c that we're talking about here is always, always, always the hypotenuse. Hypotenuse, yeah. All right. So Beverly participated again. Let's give Aurelio his point because he wants to be in Classroom Dojo. You are now up to 6, or negative 6, sorry. All right, from there, I need to solve this equation. Oh, I meant to give Beverly her marble and her XP. That's Brian. So Beverly, there's your XP. Let's give Aurelio his marble, Beverly her marble. Someone help me with the math. I need to solve for C. Who can help us go all the way through this and solve for C? Oscar, you gonna give it a shot? 5 squared, 25. 2 squared is equal to c squared. Therefore, 25 plus 24 is? Careful. 29 is equal to c squared. And Oscar, the final step, c is therefore equal to? How do I get c, get rid of the squared? It's the square root, yes, of 29. Now we have solved for C. Thank you, Oscar. Oscar, you can turn in your card. And Oscar's marble is in. So our final step is we need to plug it into the equation. Up here, I told you, if you have the radius and you need it to get it into the equation, I need to do this to it. Someone tell me what to write over here. Do you have a question, Ellery?
Well, I was just going to say, since you're going to square it anyways, can't you just leave it as 29 and square it? That is what.
Yes. You will skip a step by doing that. And that is what I always do when I'm writing equations as well. I'm glad that you see that. Thank you. Yeah, I'm going to regurgitate what, or reiterate, I guess is a better word, what Ellery just told us. Ellery just told us that since we're solving for the radius here, instead of writing c, I could have been writing r squared. The radius squared. That's what we were really trying to find, because this length right here is really r. It's not really c, it's r. Well, since we just found r squared, our equation up here is r squared. We don't really need to take the square root of it. We can just plug in r squared. We found r squared. R squared is 29. On this line right here, r squared is 29. Therefore, we can just write 29. Or if you want to do the long method, you can actually solve for what the radius is by finding the square root of 29 and then square root, or the square of the square root. So what we're really doing here, what we really did right here is we took the square root of 29 and we squared it. The square root of, the square root of 29 squared, those cancel out, I'm left with just 29. So of course the shortcut method is to stop at this point right here and just plug it in. But if you want to do it the full way, the long way, you can. Ask me questions now. You're going to be doing this for the homework over and over again. All right, let's do it again. Let's go even faster this time. I'm not going to be giving you the basic equation. I need someone to find the center for me. Someone do the left-hand side of the equation of the circle. I can come back here and give Ellery her XP and Ellery her marble. All right, someone help me. India, go for it.
It's gonna be in parentheses x squared plus in parentheses y plus 5 squared.
Perfect. Yep, so India did the left-hand side, and just walking through this to make sure that we really understand what's going on. India, there it is. This coordinate of the center was 2, negative 5. 2, negative 5. Which means I take the opposite of 2, which is negative 2. Opposite of negative 5, which is positive 5. So far, so good. Now we need to do that hard part again of using Pythagorean's theorem. Pythagorean's theorem with these lengths here, I will go ahead and count those up for us. This length is 1, 2, 3. This length right here is 1, 2, 3, and we're trying to find this diagonal, I'll call it R. Do it in red. Although red and green, that's not a line. Red and green are not the easiest for me to see. Maybe I'll make it blue. That length right there that we're trying to find is R. All right, I need one last volunteer to find what to fill in on the right-hand side of the equation. It's a long process. Who's going to do it? Beverly, go for it. 3 squared is equal to, are you using C or R? You can use either one. Okay, is equal to our radius squared, yes. 9 plus 9, all right. All right, so you're going to take the square root of both sides. I know I'm going really fast here, but I'll give you time to catch up. Is equal to the square root of 18. So r squared right here. This should be r squared, right?
Yeah.
So r squared, which is really what we had on this line, is 18. And there's our full equation. I will pause now for a few minutes so you can ask questions. Of course, we have one final example on the back, but you're going to be doing that one on your own. There is a bit of a trick. We'll be coming to talk at the end when everyone is finished to find the real answer, or the correct answer, I should say. But ask me questions on example 2 now before you move on individually and in groups to do example 3. No questions? All right, so you are finishing example 2 and working on example 3. Once you finish 3, you can write your summary and move on to the homework. All right, so for example 3, most people did a really good job of finding the center. The center should have been x plus 2 quantity squared plus y minus 4 quantity squared. The hard part was over here, the 3/5 units. Well, if r is equal to, I'll write it down here actually, if r, the radius, because it says the radius is equal to 3/5, the number that goes here is r squared. That's just judging by our formula up here. The number that goes there is r squared. Well, if r is 3/5, I need to just square it. That means r squared is equal to 3 squared over 5 squared, which is 9 over 25. The answer is just 9 over 25 here. So I'm going to come back over here.
That's it?
That's it. So I'm going to come back grab this r squared, delete it, and change it out for a 9 over 25. And that is my final answer. Box it. Yoink. All right. Does anyone have any questions before you write your summaries and then move on to the homework? Anna? So I got 9 over 25 by finding that the radius is 3/5. So I said r equals 3/5. Well, I don't want r. I want r squared because r squared is the number that really goes on the right-hand side. So in order to get from r to r squared, I have to square it. If I'm squaring the left, I also have to square the right. So if I square the left, I also have to square the right. So I'm getting 3 squared over 5 squared. Well, 3 squared is 9, 5 squared is 25. Our r squared value that we plug into our formula is 9 over 25. All right. Good question, good question. Any other questions? No? All right, go ahead and write your summary.